And welcome everybody to the Daily Space Weather Show. We've got another coronal mass ejection headed Earth's direction, and of course, the most comprehensive daily space weather and solar imagery you'll find in the known universe. This is the past 24 hours from SDO. Today we threw together 171 plus 131 angstroms. Flaring has been minimal. Solar activity has been kind of weak for the past few days. There is one new interesting sunspot to comment on. By the way, that coronal mass ejection came from this area right up here. It was early this morning. We'll get to it. First, some close-ups of this new sunspot. It's really only a beta-class sunspot. And there's an even closer view of that group. It's spread over a great distance, but it doesn't have a lot of huge umbrae. Let's zoom back out to the equatorial view. These are all 24-hour SDO videos, the Solar Dynamics Observatory. We'll also show you some captivating images of the southern hemisphere. There's the South Polar region. Massive plasma filament there around the South Polar area, and it's becoming a prominence as it sets in the southwest. By the way, if you think the channel is simply the best, make sure you press like and subscribe. Make sure you press like regardless. Or even press dislike. We'd rather have you press dislike than nothing. Yes, if you hate the videos, make sure you tell us all about it in the comments section. If we've made you mad because it's CGI or because we've said things like, oh, I don't know, planets are spherical or other blasphemy and whatever your crazy religion is, then make sure you let us know in the comments. We're very concerned about that. Remember, folks, the only speech that needs protecting is controversial speech. So, being free speech purists, we will not mute or delete your comments. If you're new to the channel, make sure you press the subscribe button. Get the world's most comprehensive daily space weather delivered directly to your YouTube subscription feed. Or better yet, sign up for email alerts. We'll tell you about that here in a moment. In the meantime, don't worry, we'll wait while you press the like button. You've already pressed the like button. Oh my God. All right, well in that case, press the share button. You've already shared too on Facebook and Twitter and Instagram. Well, how about pressing the comment button? And tell us how mad you are that we've told you to press like and share and comment. By the way, if you want to support the channel, one of the ways you can do it is via our paid affiliate/sponsors. So check out the Hemp Lucid link. You can find that below the video. Right in the description. Conveniently placed there. It's like 2 clicks away to get to our Hemp Lucid shop. And you can save about $5 on mushroom gummies, about $15 on stress, immune, and sleep stacks, and even more than that on the full stacks. So check that out if you are in the market for CBDs, body balms, mushroom gummies, and stacks. There's also some more stuff there, but check it out. The most popular products are the water-soluble CBD tinctures. Again, links below the video to the Hemp Lucid shop. You can also find links on the homepage if you want to support the channel by getting additional content. Our paywall is smashomash.com/smashteam. We've also got a membership service on YouTube nowadays. So if you could join that, if you want to join that, feel free. But the best place is smashomash.com/smashteam. That is where you get the additional content. It is the official subscription services site of the Smash News Network, least busted name in news. By the way, thanks to our new YouTube subscribers. Thanks to our old YouTube subscribers. These videos are brought to you in part by gold and silver level Smash Team members, also at massive personal risk and expense by Smash staff and I. Help offset our massive annual operating losses by becoming a member of the Smash Team. The best value is the gold annual paid-up subscription, smashomash.com/SmashTeam, also linked below this video, and on the homepage at smashomash.com. And welcome to the Neo Renaissance. Visit us on social media. There's even original music on the Spotify link from our record label, Golden Cat Productions. So check it out. Hit us up on Instagram. You'll find exclusive content all across the social media sites. And if you've unplugged entirely, we don't blame you. It's pretty pathetic out there with the continued ridiculous censorship. So here is the past. That is yesterday plus today. That's October 13th and 14th to date. And we're going to speed things up for this video because we've already got an annular eclipse happening. So let's kick it into overdrive here. So let's see. Sunspots have been mostly stable for the past 24 hours. No major degradation and no major growth. There's colorized magnetogram for that same period. That's October 13th and October 14th to date. We'll go over volcanoes as we do daily. Kluchevskoye continues to erupt and produce a 17,000-foot plume of volcanic ash. It's flight level 170. Flight level 070 over Sakurajima. Flight level 3030 over Suwanosejima. 10,000-foot ash plume over Mount Mayan. Popocatépetl, 22,000-foot ash plume there as Popocatépetl explodes. Fuego in Guatemala, sporadic mild explosive activity there. No indication on the ash plume size. Please don't pole vault the caldera. Also, Nevado del Ruiz in Colombia is producing a 22,000-foot ash plume as it explodes. Flight level 220. Sangay, no volcanic ash seen in satellite imagery. And Sabancaya exploding. Flight level 230. Please do not be an imbecile. Don't be an imbecile and pole vault the caldera. That could be unhealthful. And we wouldn't want that. Remember, folks, the word imbecile is underused. It's one of those old-timey words like poppycock and hogwash and malarkey. So don't be an imbecile. Yes, it's an adjective as well. So that's one other way to support the channel is by visiting the Redbubble shop. Save 20% site-wide. Don't be an imbecile. Click our links located in the description below this video. Yes, imbecile. It is also an adjective. Continuing on to the ever-popular earthquakes. And it's been a quiet day in the past 24 hours for earthquakes. There's a 90-day bar graph. I think there was only one quake of the 5+ magnitude. We will get to it. It was in the central Atlantic Ocean there at the Mid-Atlantic Ridge. And, there was a second one. It was a 5.7 at the Kermadec Islands there north of New Zealand. That was at 6:34 this morning. The 5.4 in the Mid-Atlantic Ridge was at 8:29 this morning. And let's move on to head back to space. Yes, space. There's the past 24 hours in SDO 171 by itself. That's ionized iron. We've subtracted the 131 angstroms to show you the house favorite wavelength. And there we've added 304 angstroms ionized helium to show you some additional detail of that their closest star. The 10.7 centimeter radio flux is now down to 149 solar flux units. And the Space Weather Enthusiast dashboard is not forecasting any... there's the 1-year graph, by the way. 149. 149 solar flux units is the 10.7 centimeter radio flux. So a little dip in solar activity continues here. A little lull as we get closer and closer to solar maximum. No, we're not there yet. It's a ridiculous idea suggesting that we are already at solar maximum. There's the Space Weather Enthusiast dashboard and no geomagnetic storms in the forecast. We're having a coronal hole high-speed stream subside about as forecast here. And, that's the current situation. Here's Earth's magnetic moment from space for the past 4 hours, and we've got an extremely diffuse solar wind being measured by the ACE spacecraft. That's the last 4 hours of Earth's magnetic moment from space. It's showing magnetohydrodynamic pressure, the units of which are nanopascals, and it is a low plasma pressure environment around planet Earth. On the ground, it's pretty chill as well, geomagnetically calm. This is magnetic flux density at the ground level, the Geospace Magnetosphere movie ground magnetic perturbations map. Geospace Delta B changes to Earth's B field. That's the field that goes through the magnet. We've got an interesting story about Mercury's magnetic field coming up in our cosmology segment. KP3 is the current situation, slightly elevated because of the high-speed coronal hole solar wind. KP3 is the planetary K index. And here's that diffuse wind I was talking about. Oh, that's measured by the Discover. My mistake. Oh, that's ACE and Discover. Okay. Now wait, that's just the ACE. It shows green down here. So yeah, the ACE, it's showing 0.1 protons per cubic centimeter, meaning you'd need 10 centimeters to find one proton out there. That's pretty diffuse, I'd say. Solar wind speed here only still elevated at 504 kilometers per second. I would note that the ACE is showing completely different data. Or is that the Discover? The Discover is showing completely different data. There you go. The Discover showed the solar wind speed there getting all the way up to about 565 kilometers per second there during the height of that coronal hole high-speed stream. This is expected to subside very soon here, and rather abruptly. You can expect to see that solar wind subside as Earth snaps into the coming South Pole current sheet. So it looks like another little impulse happening there, a little uptick recently in the solar wind density there as measured by the Discover. So anyway, again, we are expecting that to subside within the next couple of hours. And let's keep it going here. GOES magnetometers, they're only showing some minor perturbations there as a result of that coronal hole high-speed stream impact. The standard issue density wave followed by a decrease in the density and an increase in the solar wind speed. The telltale signature of coronal hole high-speed streams. And here is what I was talking about. That's the top view ecliptic plane field plot. And Earth is just about to snap into a South Pole current sheet here, crossing that sector boundary from the North Pole current sheet, which had that high-speed coronal hole wind stream in it. So, a new solar wind regime coming here. And you can expect that to arrive in just a few hours here. Keep in mind this data is nearly 2 hours old when we produced the video. And here's our line of sight field plot. Again, South Pole current sheet coming. And let's move to coronal holes. There's our coronal hole plot. So we've got South Pole oriented coronal holes here hanging out up near the North Pole and vice versa. Let's take a look at those from the SDO 211 angstroms wavelength. So this one here is North Pole. And then these are south. And there's more South Pole coronal hole coming in. The sector boundary crossing is kind of waving around like that at the moment. That's a 24-hour SDO video. And let's move to sunspots. I guess those are important, right? Sunspots? Is that important to the solar cycle? I heard somebody babbling on YouTube about sunspots. Anyways, current sunspot number is about 115, according to the Royal Observatory of Belgium. And here is that is our flare monitor and our solar flare scoreboard. So the likelihood of large solar flares is really not all that high at the moment. The most likely place to see one is, I believe, in this group. Well, the flare monitor is telling me it's this group down here. That must have the most magnetic shear at the moment. I would say 3465 looks like it's interesting as well. So a couple spots where we could see a large flare there. Likelihood of large flare is not really that high at the moment, folks. And let's take a look at, there's SDO 131 angstroms plus the SDO magnetogram. And we'll replace magnetogram with, there's SDO continuum. Again, mostly stable here for the past 24 hours. And last but not least, there is continuum by itself. So again, just to reiterate, no major changes in sunspots, no big growth, no big degradation, no new spots have risen since yesterday's daily space weather show. Next, energetic particles and solar flares. We did have some minor blips in the GOES proton flux. There you go. You see some tiny little perturbations there. And yeah, that's the GOES proton flux. For the past 3 days, no significant solar energetic particle events. The largest flare was a C9 point something, C9.8. Not quite an M-class event, and that was associated with a coronal mass ejection this morning. It likely does have an earthly directed component, so excited to tell you that. We're going to be likely to see some increases in the solar wind parameters sometime late in the day on the 17th. Who knows? Maybe it'll spark some aurora. It all depends on magnetic field strength and orientation and how direct of a hit it is. We don't expect it to be a very direct hit. Most of the plasma will miss Earth to the north, but we'll get to that in a moment. Next, a star chart. Oh, first, our flare wavelengths. There you go. That's a 24-hour video featuring SDO 94 plus 131 angstroms. And actually, that C-class event from this morning came from this sunspot group down here in the southwest. And the CME was actually a separate event that slightly preceded that solar flare. So that might be interesting, might not be interesting, I don't know, but here's a star chart of what's going on overhead right now in Lehigh Valley, Pennsylvania. Again, there is an annular eclipse coming, and it's probably already going to be striking by the time this video gets out there, so let's speed this up. Here is our solar system forecast from theplanetstoday.com. What happened? There we go. This is where things are today. There's where things will be in a week. Whoops. New moon coming tomorrow on October 15th. So that's where things will be on the 21st of October, and annular eclipse today. Hopefully you got your eclipse glasses. And yeah, there is the path of annularity. So it's not going to be a total solar eclipse. It'll be an annular solar eclipse, what we call a ring of fire solar eclipse. There is some of the information about it. There are some of the times when you can expect to see it, showing up at Crater Lake at 9:17 and so on. You can find articles on that at space.com. It'll be visible over a large portion of North America. And here's the map. We'll have like 25% eclipse here in Pennsylvania. So that's pretty cool. Again, hopefully you got your eclipse glasses. And did you know that you can get them from our Amazon shop? Yeah, that's also linked below the video. Did you know? Amazon.com/shop/smashomash. Get 5 pairs of the good plastic ones there. Conveniently linked below the video. Of course, it's too late to get them for this eclipse, but hey, you can go look directly at the sun with your eclipse glasses. And what about Psyche? Yeah, what about Psyche? You know about Psyche, right? You know, the metallic asteroid? Well, the mission has launched. So this asteroid is believed to have a value of $100,000 trillion or something. And this is a very reflective asteroid, indicating that it is made of metal. And there is a mission on its way, which launched yesterday. So that's an exciting story. Lots of asteroids in the news lately, having NASA recently returned some material from the asteroid Bennu. Another article there you can find at space.com. The mission to the almost entirely metallic asteroid Psyche. Today's astronomy photo of the day is the circular sun halo, which some people look at and they go, look, it's Nibiru. There, oh my God, it's proof of Nibiru, folks. Sun halo is the astronomy photo of the day at apod.nasa.gov. Seems kind of silly. And let's talk about Mercury's magnetic field. Yeah, maybe this will tell us something about Earth's magnetic field. Ooh, are you spooked of a pole shift? Did you know that Mercury's magnetic field is shifted about 0.2 of a Mercury radius to its north? Yeah, its field is off, as you can see in this image. The field is shifted slightly to the north there on Mercury's magnetic field. You can find this paper. This is, I just did a little search for this one. This is the Capon method for Mercury's magnetic field analysis. You can find that article on the interwebs. That's on Frontiers in Science. And there's an article today on SciTech Daily about it. The Bepi-Colombo mission is designed to go have a look at Mercury. So that's part of the reasoning for that. Perhaps we can learn something about Earth's magnetic fields, by looking at Mercury's magnetic fields. Interestingly enough, Mercury's magnetic fields create X-ray aurora on the nighttime side of the planet. Could have something to do with the fact that its magnetic field is shifted so far to the north, making it quite irregular, not apparently emanating from the center of the planet. So that's an article from SciTech Daily you can check out yourself. Chorus waves are what cause those nighttime X-ray aurora, as electrons are accelerated to relativistic speeds, creating synchrotron radiation there in Mercury's magnetosphere. So that might be an interesting story to go read. That's where our cosmology segment ends, and let's get to coronal mass ejections, since we've got two headed this way. And unfortunately, George Mason University does not have any coronagraphs, but that's okay, we do. And there is that CME, which likely has an earthly directed component. It happened this morning at about 4 or 5 o'clock Universal Time on the 13th. Again, we can expect that to arrive, the 14th. We can expect that to arrive sometime late in the day on the 17th. So it's not a particularly high speed. Here it comes. Get ready for it. You're going to see it first on the C2 there on the left, and then you see it pop out of the C3 on the right. We delayed that a little bit. There you go. There's that CME. So a likely earthly directed component due to its location. Well, the data's a little bit old there on C3, but there it is on C2, a great view of that. We'll also show stereo A located here. There's stereo A located where that red dot is. And here is the difference imagery on the right, the raw coronagraph on the left. So early this morning, around 4 or 5 o'clock Universal Time on October 14th, there was a coronal mass ejection. It came out of the northern hemisphere of the closest star. And again, we do expect some portion of that to be earthly directed. So there it is. There it is in the difference imagery. It's not a full halo. Most will miss to the north. Some will likely strike Earth sometime late in the day on October 17th. Here come our custom coronagraphs. There's Mercury popping into view. And there at the end of that 24-hour video, you'll see that coronal mass ejection. We don't expect to see more than a KP6 from that. Probably more like a KP5 at most. But it all does depend on magnetic field strength and orientation, folks. So only a mild geomagnetic storm is likely to be produced by that earthly directed coronal mass ejection. Here's a little closer view, and you'll see it coming out of this area right here at about 4 o'clock Universal Time, I think it was. Something like that. There you are. And it actually was not associated with that C9.8 class flare. That was a separate event, it looks like. Now, maybe it was simultaneous. And remember, folks, we say it regularly on the channel. We do not believe that solar flares cause coronal mass ejections. We believe that plasma reorientation causes solar flares. It's a very different scenario, and chicken and egg arguments really do matter in physics. So there's that. Don't get them confused, folks. Solar flares are photons in the form of X-rays. Coronal mass ejections are protons, diffuse gas blasting out of the sun's atmosphere. Completely different phenomenon. One is baryons, mainly hydrogen nuclei, charged particles, ions, and the other is photons in the form of X-rays. Solar flares are photons. Coronal mass ejections are protons. And let's get to filaments. By the way, that view, 304 plus 193 angstroms, is fantastic at showing filaments. So let's move on to filaments. And here's the El Teide, Spain ground-based solar observatory, and you'll see a lot of them. This one right here we named after Eric Weinstein. Eric Weinstein? Eric Weinstein. Somebody correct me in the comments. Eric Weinstein, we named this one after him. He is a free speech advocate, by the way. We've got some more massive filaments. This one over here could certainly use a name. And if you want to name filaments, go join us over on Twitter. Otherwise known as X for some reason, because somebody thought X is a brand, which it isn't, and it never will be a brand. It's a letter. It's reserved to be a letter. Thanks to our new followers over there on Twitter. Congratulations on realizing the Twitter account exists. It's only been around since March of 2019 with over 22,000 tweets and daily original content. Why would we be over 500 followers on Twitter? I can't think of any reason. I don't know. It couldn't be censorship, folks. It's definitely not censorship. It's got to be just a coincidence. Maybe I'm dumb and not insightful about things. Maybe that's what it is. I don't know. Maybe it's just that, folks. Anyway, here are filaments showing prominences also, and you can see some prominences there in both the eastern and western and also the southwestern portions of the closest star. And let's move on to our last couple of hours from the GOES 16 SUVI. So there you go. We're seeing a fairly inactive star right now. And let's move to bonus features. First bonus feature is charging hazards, and we've got some significant surface charging hazards there, which could cause some communications breakdowns as low energy electrons build up on the outside of spacecraft in the eastern Pacific. So some significant surface charging hazards there showing up. That is on the pre-dawn portion of the planet. And here is the GOES electron flux for the past 3 days. And let's pause for station identification. You've reached the Smash News Network. Least busted name in news. GOES electron flux here kind of low for the past 36 hours or so. No surprise there, since we've been having Earth's magnetosphere buffeted by a high-speed coronal hole wind. There's the one-year graph to contextualize the electron flux. It is measured by the GOES 17 and GOES 18. The GOES 16 and GOES 18 from their geosynchronous near equatorial orbits. There's the forecast model. And indeed, the observation was actually a little bit lower than the forecast. Not quite as low as I expected it. It was a pretty weak coronal hole high-speed stream. And let's take a look at the layer where it's measured, the F layer of the ionosphere. Feel free to pause the video in this frame if you're not familiar with the data depicted. Here's Australian Government Bureau of Meteorology's ionosphere map. And we are seeing less high-frequency anomalies than we've seen in the past days. No surprise there. Not a lot of low-frequency anomalies, though, just less high-frequency anomalies, due to the short duration and rather weak nature of this most recent coronal hole high-speed stream. Here's the anomalygram depicting anomaly in megahertz from a 30-day median. And only minor scintillation of the ionosphere has occurred. It looks like it's mostly around the south polar region. Keep in mind, it is spring down there, so it's all making sense if you understand the physics, magnetohydrodynamics, and so on. So no surprises to our regular viewers, I would hope. There's the latest image, 12:15 universal time for the ionogram and 12:15 universal time anomalygram. Here's the WHAM, the whole atmosphere model showing total electron content and anomaly and the maximum usable radio frequency and anomaly. On the left is good for GPS operators, on the right is good for radio operators. Perhaps they're both good for both. That is the Global Ionosphere Nowcast. We'll also show total electron content. Feel free to pause the video on this frame if you're not familiar with distances to those things in miles. Here's a total electron content forecast for the whole planet view, and I don't like the way that looks, so I'm going to switch to the North American anomaly. There's a total electron content anomaly from the 10-day average, and it is showing some significant high electron count anomalies over the West Atlantic, the Caribbean, the Gulf, large portions of North America, as well as the Eastern Pacific. We'll close out space weather with the latest intensitygram, or SDO continuum, and the latest magnetogram. So this one does have some significant magnetic shear. It's not looking that promising, folks. It is a beta gamma class sunspot. Not really beta gamma delta class. It still could produce large flares. That one there is that's just beta class. And then let's quickly take a look at these over here. That one's beta gamma class. Maybe beta gamma delta class. It's beta gamma class. So that's promising for flares. This one down here, that one is beta gamma class. Is it delta? I think that one's beta gamma class as well. I'm going to say that one's beta gamma delta class. And then these groups, this one's beta class. Actually, that's beta gamma class. And this one here is also only beta class, I think. That one's actually alpha class. That one only has North Pole umbre. So that's the scenario. Here's the full disk. Pretty weak solar activity here at the moment, and let's move to meteorology. It's a value-added service at the Smash News Network, least busted name of news. We're starting out looking at Saharan dust. Yeah, there's a bunch of Saharan dust here making its way across the Atlantic Ocean. Don't worry, it's going to decrease the likelihood of disasters, as this dust has a tendency to tamp down tropical systems. It tends to suppress convection. Anyway, here are the Earth's air masses. These are the surface winds of the eastern world. Strong low here. That typhoon moved way to the north. Headed for the Aleutians, it looks like, folks. Here are the jet streams of the east. Here are the jet streams of the central world. How about the surface winds of the central world? Well, there you go. How about the surface winds of the Americas? Cheers. And here are the jet streams. Next, snow. Check it out. Wyoming. It's mostly blanketed, as we forecasted a few days ago. At least about half the state there. And over a third of Colorado. Large portions of Utah, Idaho, and Montana. Featuring some accumulated white stuff. Highest totals are 1.5 feet in portions of Wyoming. Dag! Some early season snow there showing up in the Rockies. Next, clouds and fog over the Americas. That's what's going on shortwave radiation satellite. And here's a close-up of this pretty berserk thunderstorm in the southern Gulf. Some rapid convection as hot water enters the atmosphere there, west of the Yucatan. Some heavy thunder when we did show prep. Here's our weather.gov map. Some hard freezes there in the central part of the country. Even the Texas stovepipe there, seeing some frost advisories and some hard freezes there in West Texas. Here's our forecast, starting out with the pressure and precipitation GFS model for the next 72 hours. There you go. There's pressure and precipitation. More heavy rains coming to the Pacific Northwest. And a strong system here moving across the mid-Atlantic states. And a very strong low here to form off the coast of New Jersey. Here's our jet stream forecast, and cold air is going to be making its way across the eastern U.S. as well. There's a 72-hour GFS jet stream forecast, the 250 millibar winds. Last but not least, the temperature anomaly forecast. Again, the GFS 72-hour. Keep in mind it's in degrees Celsius. As cold Canadian air makes its way from west to east, the western portion of the country there is going to have a lot of hot air. A lot of hot air there, especially west of the Rockies. Continuing on to our lightning mapper. That's the past about 10 hours, and check it out, quite a significant lightning storm here happening in southern Mexico. See all those strikes? It has calmed down since about a half an hour ago, but still quite active lightning there in the southern Gulf. It was at over 600 strikes per minute when we did show prep. Now it's all the way down to 200 strikes per minute on a global basis. We'll close this mother out with U.S. Doppler radar, clouds and fog over the U.S., and water vapor. Alaska's getting some precip, as well as Pennsylvania. It's a cold, dreary day in PA. Rain there stretched all the way from Wisconsin to South Carolina. Here's clouds and fog over the lower 48. And there is your water vapor map. Looks like clear skies over most of Missouri, southern Illinois, Kentucky, and Tennessee. Here's your recap. Ground-based systems known as U.S. Doppler radar, which show vertical motion in the air column. Space-based systems which show infrared radiation depicting clouds and fog, even at nighttime. Space-based systems depicting water vapor, as in all of it. That's what you should use when your Doppler is unclear. Anyway, thanks for tuning into the Smash News Network, Least Busted Name of News. Get out and view that annular eclipse if you have clear skies, which we will not have in Pennsylvania. Good luck. Hopefully you got your eclipse glasses. Visit our links. Press like, subscribe, share, etc. See you soon. In the meantime, I'll have been your host, Dan, a.k.a. Smasher Mash, signing off. And may that solar wind be at your back.